Welcome to Geometry Pre-AP. Today we're going to do some video notes on symmetry. So again, make sure you're writing down the things that I have in the highlighted box. All right, and I'll pause the video so you can get those things down. All right, so line symmetry and line symmetry and point symmetry. Point symmetry is a figure that has symmetry if it has a 180-degree rotational symmetry. That's point symmetry. So we'll just discuss what these things in rotational symmetry are. All right. So first thing, a line symmetry. A line symmetry is just if I can put a line down a figure and that figure is exactly reflected so both sides can be folded over to create a congruent shape. So it divides it into two congruent halves. Okay, rotational symmetry is something different. Rotational symmetry is more of if I have a figure and I can rotate it. So if I take a figure, let's see if I can find them we like. Okay, yeah, let's look at this one. Okay, if I take this figure right here and I try to draw a line symmetry and I draw this line right here, it doesn't divide this figure in half because I couldn't fold it over on it and it'd be the same thing. All right, but what I can do is I can take this figure. All right, I'll make a copy of it. All right. Oops, I meant to copy that. All right, so here's a clone of it, okay? And so there's anything about this stuff, the tools that we have, okay? I can spin this figure. So if I take this figure right here, and that's 90 degrees, and this is 180 degrees, I have the exact same figure again, and that is rotational symmetry, okay? And so rotational symmetry is being able to rotate the figure a certain number of degrees and get the exact same figure back again, okay? Okay, and so a lot of times, like if you look at this triangle here, it has multiple lines of symmetry. So this one has a line of symmetry here, here, and here. And so therefore, if I take 360 degrees and divide it by that 3, I get 120, which means this one's got 120. So every 120 degrees, we get symmetry again. It's a rotational symmetry. And for this parallelogram, it took me a whole 180 degrees to get that rotational symmetry. Now, point symmetry is a figure has 180-degree rotational symmetry, then it has point symmetry. So that's just for a specific 180-degree rotation. So if you get the same figure after rotating 180 degrees, you have point symmetry. All right, so does this triangle up here have point symmetry? Yeah, it does because it has 120 degrees. Well, actually, no, it doesn't. It has 120-degree rotation, so it doesn't have point symmetry. So this one has rotational only, but like a square would have rotational and point symmetry because it has rotational at 90 degrees and at 180 degrees, which means it has the point symmetry also. So we need to be able to just determine between reflectional symmetry, rotational symmetry, and point symmetry. All right. So when you're identifying lines of symmetry, you have to be able to reflect that figure over. So in this case, this figure has lots of different lines of symmetry. And so we end up with 6 lines of symmetry. So we have 1, 2, 3, 4, 5, 6. Because if we go to that one, it's the same line again. So this is 6 lines of symmetry. So 360 divided by 6 lines of symmetry means we have rotational symmetry at 60 degrees. Okay. And so here, identify rotational. Does the figure appear to have rotational symmetry? So for the first one, no, we don't really have a center point, so we don't really have anything to rotate about, and it just won't come to be rotational symmetry. The star, on the other hand, it does, and so remember that I can put lines of symmetry in here. So I've got one here, one there, one there, one there, and one there, and so I end up with 1, 2, 3, 4, 5 lines of symmetry. So 360 divided by the 5 gives me the 72 degrees. Now, does this one have point symmetry? No, because at 180 degrees, it's not the same figure again. It's chunks of 72 degrees. Okay? All right. And so determining between rotational and reflectional symmetry. So the pentagon here, we can put all the different lines in here. So it has reflectional symmetry and it has rotational symmetry. This R has no reflectional symmetry and it has no rotational symmetry because I can't take it and spin it. And so therefore it is what it is, and so therefore I cannot spin it and get a figure. Now if you wanted to check with that, I guess we have little tools here. So let's just grab this little R right here. And so here I've got this picture of this R. And so I can take this R. This would be 90 degrees, not the same figure. This would be 180 degrees. That's not the same figure again. So since it's not the same figure, I don't have any rotational symmetry. I'd have to go all the way back here at 360, and 360 is not rotational symmetry. Okay, it has to be 180 or less to be rotational symmetry. And if it has that 180 rotation, that's point symmetry. All right, look at the M. The M has reflectional symmetry. You can draw that line right down the middle. Doesn't have that rotational symmetry. The S, on the other hand, it does. And so we can go and show it right here. I'll just grab a little snapshot of that S. So here's my S. So this is 90, not the same. There's 180. Oh, I've got the same figure again. So that's rotational. And since it's a 180 degree rotation, it also has point symmetry, because it took 180 degrees to rotate it. So this one has no line symmetry and only rotational symmetry. And that is the end of this video.